Today I'll be showing you how I've made this fire hazard that happens to work as an e-bike battery. This is a 10S 14P battery. Its dimensions are wonky, but they fit the case that I'm presently using. It's made from 7 10S 2P scooter cell batteries. You can get these on batteryclearinghouse.com. I bought about 10 packs of these for 130 plus shipping. I'm only using about 7 in this build, but you shouldn't assume that all 10 will be usable. The black casing on each of them can get taken off with just removing the 7 or 8 screws that are underneath some black goop. Comes out easily enough with just a screwdriver. I next checked the voltage on each cell grouping using the letter that I wrote down on each pack as a reference for keeping track. I checked the voltage on every single pack and then start sorting the ones with the lowest voltage out from my project. Of the 10 packs I have here, I've highlighted the low voltages that are at or below the 2.2, 2.3-ish rating, and you can see there's 4 that stand out. Thing is, that's 4 out of 10, and I need 7 for this build. Now, this is actually my second time building a battery like this, so I have 3 left over from the other one where I also took out the 3 worst ones. And one of those worst ones is better than my best worst one of this batch, so I'll be swapping that in for this build. At one end you can see the remnants of the BMS that used to control these things when they were still installed in the scooters they used to power. I don't actually need this aspect of it in my build, so I'll be removing it. The little tabs you see up here snap right off easily enough. I've not experienced any arcing, sparking, or fires from doing so, so I've done so as every one. Once you get that disconnected, you're able to access the nickel strip that you can cut at the seam between the BMS and that long board, or you can pry the nickel strip off of preferably the BMS because, well, we don't need the BMS, so why damage the other board? Or you can desolder it if you want to have that extra little bit of length later on. You'll see. I put together the 7 that I would need for the build, made sure 3 times that I didn't swap positive and negative on any of them. I then glued it with this plastic welder and works well enough, no real problems. I clamped them together and let them sit for about a week because I got a little bit lazy and had other things to do. The voltages on these packs was all over the place, so you can't just connect them in parallel as is. You have to equalize them to each other before making the connections, otherwise they can damage each other from connecting them. I'm, in this case, connecting all of the positive most cells together because that in itself won't be enough to complete a circuit. Please ignore the jump cut. The other video wasn't very good, but the process is exactly the same. The positives are all connected together, but the negatives are all independent. My preference is to use a key to reference what cells are at what voltages and when to connect them to each other in what order. I'm using a charger board here called a TP4056. They are quite expensive at about $1.30 if you want to buy one, or a 10 pack you can get them about 80 cents each, or if you really use a lot, buy a 40 pack and it's about 39 cents. Once you've got it charging, the first couple get connected together fairly quickly because you're charging only 2 at a time, 4 at a time, 6 at a time. After I've got 2 or 3 sets together, I only had to check it every 20-30 minutes for the next 2. and the ones after that took a couple hours because you now have this one little charger charging several more cells than the beginning, but it got there. Keeping the strip taut during this portion was quite difficult, and I decided not to even really try. So instead, I used the same strip repeatedly from one section to the other and took it off after I got them all together. I just used a lower setting on the spot welder. Once they were all connected, the strip comes off and a good fresh one comes on, one after the other, allowing me to keep it taut. I should probably mention at this time that except for the main positive and negative, these nickel strips don't need to be very big. What they do is keep the cells you are putting in parallel equalized with each other, and the BMS leads will connect to them. Neither of these things are particularly high in current. The high current portion is internal in the pre-built assemblies we're using. The initial equalization was done by that little charger fully charging each parallel set before I started connecting the next set together. But there may come a time that you need to re-equalize. For that I install some balance leads, specifically two sets of 5S JST XH connectors, one set on the first 5 in series and one on the last 5 in series. The wire colors don't make much sense to me, so I compared the connectors to its corresponding port on my IMAX B6 to find positive and negative. Now, before you go and post that I could have charged the cells with this, the magic smoke has left this box when I had a setting wrong and the last time I tried to use it. Anyway, by comparing the connector to the IMAX, you can see the positive is the leftmost wire, the black wire, and negative is the rightmost wire, the green one. Got that? Positive is black, negative is green. Now that they have been identified, I tinned the ends and put a small bit of solder on one end of each strip, alternating the side I put it on, then starting from the negative most wire and negative most part of the pack, I connected the wire leads to the pack. Connecting the sense wires of the BMS was done in the same way. The BMS's connector had one black wire and 10 red wires, so to avoid confusing myself, I started with the black one, and using the connector I would move up it, connecting the next in series until the final wire connects to the battery positive. This is a cheap Chinese 10S 35 amp BMS that has worked for me, but if you want yours to be less of a fire hazard, or more, you can use whatever BMS you prefer. Once they're all connected, you're left with a bit of a bird's nest of wires, and the next thing to do is not to connect the BMS. You need to check your connections. You should see about 42 volts checking between the first and last lead because one cell is 4.2 at full charge and there's 10 of them. You should also see increments of 4.2 by checking each port on the connector. If you keep a probe on positive and move down the holes individually, it's a bit simpler to check them all. A couple layers of Captain tape and it's no longer a dropped screwdriver away from blowing up in my face. The next thing to do is to add power wires. I'll be adding the usual red and black for positive and negative, as well as a green one at the halfway point. This green wire is used when equalizing the two 5S packs this battery can be treated as, because of the two sets of 5S balance leads. It'll be the negative of the first pack and positive of the second. These wires got soldered to some nickel strips, which is then spot welded to the battery, and I finished wrapping it in Kapton tape. I also reused one of the black plastic plates that each battery came screwed to. It got 3 holes just about the size of the wires and acts as a bit of a strain relief. All that's left is to connect the battery's negative to the BMS B negative pad, more of the same thickness wire to the on the P negative or the pack negative, the charger leads to C negative and battery positive, and lastly, whatever connectors it takes to be compatible with the e-bike's motor controller. With this, I can go about 40 miles before I see a dip in speed from 25 miles an hour to about 20. One pack weighs about 16 pounds, and I intend to install both packs in parallel before spring. The reason that I'm going to do so isn't really much more complex than because I can. I mentioned that my dimensions were awkward but fit my case. Well, here's my current setup and here's my future case. And as annoying as it may be watching one of these videos, there's not actually going to be any portion where it shows me riding the thing because it's February for me and it's about 20 degrees outside right now. So, bye.